So here's what we did in section 11.1. What kind of problems do you think are going to catch my eye when I look at section 11.1? Yeah, f of g of x and g of f of x. So definitely a couple of these. I like example H a lot because it's kind of combining a couple things in a pretty friendly way. There's not much calculation to do here, but you do have to know what's going on in terms of f plus g of negative 5. F of negative 5 means you go over here to the x-axis, you find negative 5, and you go up and find the y value for f. The output from that function is 3. So there'd be 3 plus g of negative 5. G of negative 5, similarly, go down here, you get negative 3. So 3 plus 3, the answer would be 0. Function composition, again, a good one. You got to do the inside function first, followed by the outside function. G of negative 1 would be negative 2. And then when we plug that in for f, f of negative 2 would be 0. So definitely function composition, understanding it in relation to this graph would be a good thing. And those are the big things here. That led us into section 11.2. Section 11.2, we started talking about inverse functions and other stuff. We talked about one-to-one functions. Inverse functions, we started out by looking at the relationship amongst our mile roads here in the Metro Detroit area. And let me see if I can't just pick up my class notes from that section. So that's down here. I'm missing something. Yeah, here we go. So a few conclusions from inverse functions. What's the relationship between the graphs of inverse functions? Do you remember? Does this jog your memory? Yeah, they're mirror images of each other around the line y equals x. To find the inverse function, you follow these steps. You replace f of x by y. You interchange x and y, solve for y, and then replace y by f inverse of x. That last thing always gets forgotten by people, and it's going to cost you a point. I hope that's not you. So our function in inverse pairs are going to be mirror images around the line y equals x. By the way, is this a one-to-one function right here?
No.
Why not?
Doesn't pass
the, what kind of line is that called? Horizontal line test. Yeah. So something that passes the horizontal line test is a one-to-one function. I'm assuming you're starting out with a function. So D and F are one-to-one functions. So is E and G. H passes the horizontal line test, but what does it fail? Vertical line test. So it's not a function. All right, good deal. Make sure you can find an inverse function. So make sure you can work your way through all those steps. And I think we did some of that stuff on the following day here. So let me scroll down. Yeah. So this is what your inverse function calculations would look like. Notice that in both of these, I end up with that F inverse notation. All right, I need to see that. Let's see, you know what? I need to scroll down to 11.3. 11.3, I believe, is where we started introducing exponential functions. You should be able to shift these graphs around. There's a couple things I'm looking for when you shift that graph around. I want to know where that point at 0, 1 gets shifted to. That's where I'm going to judge you most critically. So this one has been shifted to the right by 31 and up by 17. That means the point at 0, 1 is going to get shifted to the point 31 and 18. Remember, because you're starting out at 0, 1, so that vertical shift almost tells you where that point goes to. It's just going to be 1 above that. I'll give you the formulas for compound interest. You just need to be able to use them. So there's your formula for compound interest. Make sure you can use that one. We introduced the logarithm, and you guys did a great job in working through this kind of stuff. That is starting out with an equation, figuring out, well, what's log base 9 of 81 equal to, and then rewriting it using exponents. Expect something like this, to start out with an equation in logarithms and write it with exponents, and the other way around. You guys did great on both parts of it, starting out with an equation in exponents and writing it with logarithms. Did I mention memorize this? Definitely have that memorized. Write it on the top of your test. We graphed the logarithmic function. Do you remember our trick in graphing this? One of the tricks you can do is just rewrite it using exponential functions and then plug in values for x. Plug in values for y as opposed to plugging in values for x. So we did that right down here. We started out with log base 2 of x and rewrote it as 2 to the y equals x. And we just fed in values of y to get values of x. So nice. And then we had continuously compounded interest. And where's our functions there? Our functions of e to the x look a lot like our regular exponential functions. Make sure you can shift those as well. And then today we finished up with properties of logarithms. What kind of stuff from today do you think you should know? What stands out to you from today's lecture? Nothing? I hope you remember the bases here. Log base 10 is just as written as log of e, or log of x. And then log base e is ln of x. Make sure you know the properties of logarithms. Where did I put all those? Right here. Here's your properties of logs. And of course we need to add one to that, and that's a to the log base a of, let's just do a y here equals y. These are your inverse properties of logs. This one, rats. This one and this one. These are just showing the relationship between the logarithm function and the exponential function. They're inverses. These things cancel each other out, and you just get the y here and the r here. So those are very handy to know. We'll need those more in section 11.7. But expand things with logarithms like we did here, and some more like this. Definitely expand some of those and expect some of those. This one's a good one. You'll probably see something like this, for the simple fact that I want you to make sure that you take care of that negative here. When you do the log of a quotient, it's the difference of the logs, but you have to distribute that negative and be careful that it distributes itself to both terms. A lot of times I'll get people giving me this, minus this, plus this, without the parentheses. If there was a plus here, that would be wrong. It'd cost you a point, so be careful with that. The change of base formula will be given to you for those of you who have an older calculator, but if you have a newer calculator, that's great. Should be easy for you. All right. This is just using your inverse properties of logs and exponents to simplify these. Again, I hope that those are some easy questions. Comments or thoughts from you guys? Charlie?
Why does it cancel out to 0?
You mean right here, log base 3 of 1? So what you're looking for is what exponent of 3 gives me 1? And 3 to the 0 power gives me 1. Or any time you have log base b of 1, what power of b gives you 1? The answer would be 0. So that's kind of one of our general properties of logarithms. So appreciate you asking. Anything else? All right, let me close it down.